I'm going to start quite basic with this topic, but we are going to be doing in this lesson some more advanced things. I'll put some key timings into the video so that anyone who's completely happy with swapping fractions, decimals and percentages can skip forward to the second part. But it's worth a look at the first couple of examples. Then I would like to do a little bit of a description of how fractions, decimals, percentages and ratios, how they link to each other, why you might want to use them instead of something else doing the calculation. A lot of mathematicians will, to a certain extent, swap between them, and they'll do it rather readily. The most common switch is people changing percentages into decimals, so that when they come to put numbers into the calculator, they're being a little bit more efficient. And that's one of the later things I want to talk about. So let's start off with a couple of nice simple-ish questions. I've got a fraction, 9/20. So I've got a fraction 9/20. I'd like to write it in all four forms. Notice I also want to do a ratio, so we need to think, what does this mean? And how can I convert it into a ratio? Notice the ratio we're doing is only comparing two parts though. You should have done a bit with ratios. So the first question is, what can I easily change a fraction into? Well, when the denominators here is a 10, 100 or 1,000, we know exactly what a percentage is. When we know what a percentage is, we can easily turn it into a decimal. But we'll do a number of little roots on these to convert them. So let's have a look first of all at what I could do to turn this into a decimal. Now, some of you, what we start off with is equivalent fractions. I love equivalent fractions. It's one of those ideas that you really, really, really need to be comfortable with. Once you can deal with equivalent fractions, you can also deal with the proportions we were dealing with last week. So equivalent fraction leads to proportional reasoning. This is why I keep banging on about these and using equivalent fractions. I keep talking about equivalent fractions and ratios. The techniques I use are actually the same. So do try them, please. So we need to try and turn this, how can I change this denominator into something I can write as a 10, 100, 1,000 easily? Well, some of you may say, well, I'm going to half it. So I'm going to half top and bottom. Half the bottom gives me 10, top gives me 4.5. That gives me an equivalent fraction. And what happens when I'm dividing by 10? Each digit moves one place, less important. The digits move, not the values. So when we're dividing by 10, that means all digits move one place, 0.45. That's one way. Some of you might say, well, I can change the 20 into 100. Well, I'm going to multiply by 5, top and bottom. So 5 times that is 45. Dividing by 100, same as we did below. Decimal point is here. Each digit moves 2 places to make it smaller. That's dividing by 100. Each digit moves 2 places smaller. I've got 0.45. Good, they're the same. You can do lots of messing around with these to get different variations. So we've got these ones here. Both of them giving us our decimals. Either way works. What's lovely is when we get to here. Once we've got a division by 100, that immediately tells us, if I multiply both sides by 100, it tells me what this is as a percentage. So the percentage is that number, 2 decimal places. From the second decimal place, that is equivalent to 1%. Okay, so we've done the fraction, we've done the decimal, and we've done the percentage. Actually, I'll do FDRP on there. So we've done FDP. Last part, and this is the part we want to turn into a ratio. we need to think, what's the meaning of a fraction? Now, the meaning of a fraction normally is, this is some part of something, and the bit below is the whole. Now, what ratios do is they can split fractions into a part and compare that to another part, which has the advantage that we can actually combine them. So we've got part 1. What's part 2 need to be to make it up to have the same total? So the total is going to be, I need to think, and I'm going to think, oh wait, the 20 is the whole. I've already dealt with 9 of them, so I've got 11 left over. Now, here's a little Mr. Boothroyd special. I tend, when I'm looking at percentages, to also write down what the total is as if it was on the ratio line in the same manner when we're dealing with wholes and parts. If we're dealing with scaling, this isn't as useful. But for wholes, parts, comparisons, so that's the whole on that side. When you're dealing with sharing and things, that bit becomes useful. So that's a Mr. B extension. It just helps when you're doing ratios for quantities. Through this week we're going to be doing some other bits with ratio as well, to do with scales and maps. So in all the exercise you're doing today, which is a card matching exercise, if you can print it out it's so much easier. If not, you'll be writing things into your book onto a page, but I'd like to see attempts at how did you do the methods of converting one number into another. So let's scroll down, do a couple of others. We've done a fraction. Let's do one of the nasty fractions that people are really horrible, worried about. Let's go for, if I do 5/6. Changing that into tens, hundreds, thousands is really difficult, and the reason is because of getting a 3 on the bottom. There's certain fractions that you need to recognise and be able to deal with, and one of them is thirds. So you need to recognise that 1/3 is 0.3333, and it keeps going. Okay. So what I'm going to use is, if you can remember that one, what I can do is I can manipulate this 1/3 using ratio rules. Now the rules with ratio are each line can only create another line by multiplying or dividing on its own. If you've got multiple lines and they're showing the same value, so I'm just showing multiple decimal places in there. So I want to turn this into sixths. Well, the denominator needs to get twice as big. So if I divide by 2, or multiply by a half, that's going to tell me 1/6. And this is where you've got to work through your division carefully. Those of you doing Russian division, by all means use your own method, but I'm just going to show in between why this one might be a little bit nicer for the decimals. I find Russian division is difficult with decimals. So 2 into 0 doesn't go. I'm now passing the decimal point, nothing carrying over. 2's into 3 goes once, 1 left over. 2's into 13, 13 is 6, 1 left over. 2's into, right, I'm repeating. So 0.33333, half it to give me 1/6 is 0.16 occurring, or 6 occurring. The reason I'm showing the extra ones is to help with the calculations. So I just lost the bar on my division. So we've got to the point where we can actually calculate 1/6. Well, 6/6 we know is 1. Now this is the second rule of ratio arithmetic, is if you have 2 complete lines, you can add or subtract. So I'm going to subtract 1/6 from 6/6 and 0.1666 from the 1 above. If I've got a whole line, I can add and subtract. So I'm going to subtract in this case. You might want to do this times 5. It can get messy. We'll try that in a minute. So 1/6 minus a sixth is 5/6. And then I've got to subtract. Now remember, this keeps carrying, so we're going to have a quick look, see what happens when we do this earlier digit. We've got to borrow all the way back here. Now some of you will probably cascade 9s to get a 10. I tend to do a payback method, but this is equivalent to the number 1.0. Payback method is you just borrow a 1 and then you pay it back at the bottom here with this other 6 here. So the 666, we can't actually take this away from 10. What we actually do with the recurring digit is we take it away from 9. So that 10 minus 6 we think is 4, but when we look at the next column, look what happens. We've got 9 minus 6 is 3. 9 minus 6 is 3. This recurring keeps going that way. So this is actually a 3 as well, because next to this there's actually a 6 being taken away from a 0. So 3, 9 minus 1 is 8, and we've got 0.833333. And the 3 is the only digit recurs. That's what the dot goes on. This recurring digit, the recurring digit must be on the digit that repeats. That's the recurring digit. Only the 3 repeats. Okay. So we've now turned this into a decimal. If we know we've got to go to percentages, always write the decimal at least 2 decimal places. So this now means that 5/6, we've got all of these percentages, the 5/6 I wanted above, I can now do is 0.83 recurring, 2 digits is gives me 83, and there's an extra digit continuing. Remember, there's an extra 3 after this, so there's a 0.3, another one after that, 0.3. So the first decimal place, and it's only decimal places we ever show recurring. You don't show it on the whole number part. So 8.333%. We've got the fraction, we've got the decimal, we've got the percentage. Now the percentage here might be a little nasty to deal with, but look at the fraction. We've got 5 parts. So part 1 is 5. What's left to make that up to the total 6? 1. So we have a ratio of 5 to 1 with Mr. Boothroyd's extension, which I'll change colour for. It's not standard practice, but that's why I put the bar on the end. It's my extension because it helps me with some calculations when it comes along later. Okay, so this is the nasty numbers with fractions. If you have to, and you're able to use a calculator, it's quite simple to do fractions. 5, wait, turn the calculator on. 5 as a fraction of 6. If you haven't got a fancy calculator, this backwards L means the 5 is over the 6. Gives me the fraction, and if I press the fraction button again, 0.83333333. Now, it's not easy to get calculators to do ratios, and this one doesn't, nor do the Casios generally. I have seen a Hewlett-Packard that tries to do it. I think that colon, let's try the colon. That doesn't seem to do anything. I've got to dig out the manual to find out what that means. I have seen a Hewlett-Packard that will convert to ratios as well, but not Casios generally. Right, let's do done that. Let's do a ratio. Let's take the ratio 7 to 1. Now, thing to remember with it, Mr. Boothroyd's extension, what's the total? 8. So now I can say what the first fraction is. The first fraction is 7/8. The whole number needs to come down for the denominator. Now we need to convert it into numbers that we can multiply. When you see powers of 2, nice thing to think about is I can multiply by 5s. So if I multiply by 5, I get 35 over 40. Got a power of 2 going on here, so I can multiply by 5. That's going to be 175 divided by 200. I've got a 200. Let's multiply by 5 again, and that gives me 5, 8, 7, 8, 25, 8, 5, 850, 875. Over 200 times 5 is 1000. So these multiplications, if you have to, do a jot to. Times 5, 5, 5, carry 2. 5 times 7 is 35 plus the 2 carried. 5 times that is 8, 875. There you go. Do jottings if you have to, but keep them separate from the main calculation. Some of you have a habit of trying to do this sort of thing in the middle here and it gets messed up. If you regularly have to do that sort of thing, do a little section on the side for you to do your working in. This gives me my a fraction. Started up with that one, but we've complicated it to give us a denominator that's a power of 10. That means that if I take 875, 3 places smaller for each digit. Notice digits move 3 places smaller. 1, 2, 3. 1, 2, 3. 1, 2, 3. And there's my decimal point. So all of them have just moved past my decimal point. So I've got a decimal value of 0.875. That also allows me, if I take the numbers and convert it into a number over 100, that's divide everything by 10. It gives me 7.5, and this, when it's over 100, gives me my percentage value. So the ratio of 7 to 1 is a fraction of 7/8. It is a decimal of 0.875 and a percentage of 87.5. Now, in the exercise I'm going to set, I would like you to do these, show these with it, including the ratio. Even if the pairing doesn't do it, that's what I'd like you to do. So let's just check the 7/8. 0.875. Turn it into a fraction, show it 7/8 again. To turn it into a percentage, multiply by 100. And that's 87.5. Now, I did say I'll give you some tips on why. Why do people do these conversions sometimes when it's not needed? Well, if I'm asked for 0.625, let's do it as a percentage, 62.5%. I'd like to know what that is of maybe 400 euros. Okay. I need to know what that percentage is. If I'm not using a calculator, it might become a little bit difficult. You could do things like know what the fraction is. Simple fraction is 62.5 divided by 100, and the of, most of you will learn of is multiply. I like saying my x value over 400 euros, multiply to bring it into the next column, well, so multiply by 400 to get it off the bottom. This is my proportional reasoning. The percentage quantity over 100% is the same. That means that 400 divided by 100 times this number, and I can multiply. So it goes 0, carry a 2 into the next column, 4, 8, 1, carry 1 into the next column, 4, 24 plus 1, 5, carry 2 into the next column, says 250, 1 decimal place. That's one method for doing it. Another one is 62.5. Well, I've got a number here which is very close to being a nice thing over 1,000, so I could turn 62.5 over 100. And change that into a 62.5 over 100, change that to 625, divide by 1,000. These numbers all share by 5. So share the bottom by 5 is 200. 6 divided by 5 is 1, carry 1 into the next column. 12 divided by 5 is 2, carry the 2 into the next column, and that gives me a 5. Just a quick recap on that. I'm dividing the top by 5. 6 goes once, carry 1. 5 into 12 goes twice, carry 2. 5 into 25, 5. Gives me 125 over 20. I can do this, keep going, they're both divided by 5 because look at the last digits. So I divide by 5 again. On the bottom, on the top, doesn't go into the first one, but this now becomes 12. So 12 divided by 5 is 2, carry 2 into the next column. 5 into 25 goes 5 times. Did the same thing on the bottom, 5 into 2 doesn't go, 5 into 20 goes 4 times, nothing left over. Again, these both divide by 5. Hopefully you all recognise 5 divided by 8. And now I could do my calculation with a fraction. 5/8. Again, I can say x over 400. Bring it to the other side as I've multiplied by 400. And now I've got 5 over 8 times 400, and I recognise that 8 into 400. We all go. 8 goes into 400 50 times. 5 times 50, 250 euros. The last quick one, the reason for knowing about percentages is really to do with calculators. This is a speed up that a lot of people do. Rather than typing the 62.5, you think, what's this as a decimal? Well, take the percentage, turn it into what's called a multiplier by moving all digits 2 places to the right. And that means if I take my quantity and multiply by 0.625, do that on a calculator, it should give me the same value. 400 multiplied by 0.625 gives me my 250. My caution is make sure that before you start trying to do these things, you've laid it out as a fraction. You should really think about the problems separately. This 62.5, do 62.5 over 100. I know that is 0.625, and that is equal to my x divided by 400. The reason I'm encouraging this is there are problems where if you're not given the asked what is the result, but you ask for the start value, these values change around. And lots of people mess up the calculation because of it. So be cautious about using this quick method when you're not sure about using percentages normally. Once you're completely happy with this method, thinking what lines up with what, then by all means do use the speed up method. But this is why people do it. But a lot of people make mistakes because they try applying this when it's not appropriate. So stick to this method. Stick to thinking through the problem, then doing the maths separately. Okay? Right, there's going to be a second video with what you're doing for your exercise. So see you in a few months.